thing that seems like it's conserved, at least perturbatively, both by electromagnetism and by the nuclear forces, ends up being eaten by gravity. And people like to promote this, we're talking about quantum gravity now, to a general principle that quantum gravity doesn't respect any global symmetries. It doesn't respect nuclear number symmetry. It doesn't respect any of these symmetries. And that's a whole other can of worms that we can open some other day.
I recently wrote this blog post where I speculated that sample efficiency during training actually hasn't improved that much over the last few years, and rather, we've just dramatically improved and widened the data distribution. And I was having dinner with friends recently, and then I had this idea of how you could get some empirical information on this question. There's this nano-GPT speedrun where people compete to train Karpathy's GPT-2 baseline to a fixed loss with less and less compute. The training data is frozen, so I wondered if the loss curves over time of each record could tell you roughly how fast sample efficiency is improving. So I pulled out my phone, I dumped this idea into a voice note in the Cursor app, and I went back to dinner. And then I got a notification about 15 minutes later. The Cursor agent had cloned the modded nano-GPT repo. It had analyzed